what we've done so far is we've done arithmetic sequences, which is when we just have like something that has a common D and commas. So like 3, 5, 7, 9 goes up by 2, right? Or if I went 7, 5, 3, and went down by 2, that's still fine. That's an arithmetic sequence, right? Then we did arithmetic series, where I said, okay, now take this sequence and add them. So series is a sum, right? So we have to be able to tell if it's arithmetic or not after today, because it's not just going to be arithmetic. Good thing is it's two options. It's arithmetic or geometric. Those are the only two options we have. It's not like we give you 14 different types of series you have to figure out. So arithmetic has a common difference, which means you go up or down by a certain value, right? So term 2 minus term 1, or term 3 minus term 2, and you can find out what D is. Geometric goes up by a constant value as well, but it goes up by multiplication. So it'll get really large fast or really small fast. So if I multiply by 2, and I started with 2, I have 2, then 4, then 8, then 16, then 32. Those numbers are climbing really quickly, aren't they? Because geometric is an exponential function, so it'll grow really fast or it'll decay really fast. So arithmetic, the way we can tell is we do term 2 minus term 1, term 3 minus term 2, and they go up by the same value, right? If they don't go up by the same value, they're geometric. Geometric, you do term 2 divided by term 1, term 3 divided by term 2, and you get the same ratio, okay? So the difference is just subtraction or division. That's it. That's all. Nothing crazy, okay? But before we do that, we're giving you a little bit of information so that you can actually solve a geometric for n, because you guys don't have the actual knowledge yet to be able to do that. But it's not crazy hard, okay? So pay close attention. This is totally brand new, and it'll help you for 30. When you have a situation in which the exponent is a variable, so up till now, we've never had a variable exponent. We've always had a number in the exponent, like a 2. Worst case, even in grade 10, we had negative 2. And then we had to flip it to make it positive 2. We had to move the exponent to the denominator, or move it from the denominator to the numerator to make it positive. But we always had exponents that were numbers, okay? Now, what we're going to have with the exponential equations, or in this case geometric, is we can have a variable in the exponent, okay? If we need to find n, or the variable in the exponent, we're going to have to do the same steps every single time, okay? The first step, and this is just watching, the first step what we're going to have to do is stop ourselves from making this be 10. You can't go 5 times 2 is 10 to the n minus 1. That's the very first thing you're going to have to stop yourself from doing. So if you have 5 times, you cannot put these together. That cannot happen, because the only way you can put together two things with an exponent is if they have common base. So you were taught that if you had like x to the 2 times x to the 3, you could add exponents and you could get x to the 5. You were taught that in grade 10. Okay? We can't put these together because they're not both 5s, and they're not both 2s. The only way you can put them together is if they were the same base. If they're both 2s or they're both 5s. So we can't do that. So because we can't do that, the first thing we're going to actually do, instead of putting these together, which is a big no-no, you're going to get it wrong every time, is you actually just divide the 5 over. So we just divide both sides by 5. So you're just paying attention. You don't have to write this. It shows it in your notes. So I divided by 5, and now I have this lovely thing, right? I got rid of that 5 issue, the 5 that was stuck by that 2. I didn't put them together, bless you. I divided the 5 over. Does that make sense? So if you're someone who's like, I'm totally going to try and multiply those together, you leave yourself a star, star, star. Cannot multiply these. And by I say, if you're going to be that person, half of you will try and do it. You all do in grade 12, you all do in grade 11. You put them together and make it be a 10. If you're like, that could be me, I would highlight it, I would circle it, I would star it and say, you cannot put these together, must divide it over. Okay? That's common error before we even start. People put them together. All right. So I divide the 5 over, and now I have this. Now this is the key thing. In order to solve these, I have to make both sides be the same base, and you make them be the smaller base. Base being the number down here. So we're going to make them both be base 2, because that's the smaller number, correct? So in your calculators, everyone try this out. Your base 2, you're trying to make this be a base 2 as well. So we go 2 to the exponent 2. So in your calculator, you go 2 to the exponent 2. The exponent sign is below the clear sign, I believe. So you go 2, exponent 2, enter. What's the answer? 4. Is that 128? So we go 2 to the exponent 3. What's that? 8. Is that 128? No. 2 to the 4. 16. Still not good. 2 to the 5. I get 32. Is that 128? Nope. 2 to the 6 is 64. Try 2 to the 7. Did I get there? So that's why this one here is written as 2 to the 7. Because 2 to the 7 is 128. How did I know to go 2 to the something? Because this side was a 2. If this side was a 3, I'd go 3 to the something. If this was a 4, I'd go 4 to the something. Right? You always have to make them both be the same base. Do you see that? Now, total side note. If I give you 2 to the smiley face equals 2 to the 4. If that's true, what can you tell me smiley face must equal? 4, right? If this is true, if 2 to the smiley face equals 2 to the 4, then these would have to be equal, wouldn't they? Technically? So that's why, after this next step, if we have 2 to the n minus 1 equals 2 to the 7, I can just say, oh, n minus 1 would have to equal 7. Because if 2 to the smiley face equals 2 to the 4, then smiley face would have to equal 4. Same thing over here. 2 to the n minus 1 equals 2 to the 7, then n minus 1 must equal 7, right? Because they're both base 2 to an exponent. And then I just have to solve it out. Add 1. And I get n equals 8. I'm going to sneeze. Oh, that was right by the mic. Sorry, whoever's listening. I tried to pause it, but I wasn't out. It was going to be bad. So, you're welcome. They get to hear that as tsunami sound. Okay. So, we have 2 to the x equals 128. We're going to do this one. So, what base do we have to make both sides be when I have a variable in the exponent? The smaller base. What's the smallest number out of 2 and 128? 2. So we're going to try and make them be the same. We already did this. What was 128? 2 to the what? It was 2 to the 7, right? Now I say, once to the same base, 2 to the x equals 2 to the 7, then what? X must equal 7. Exactly. Not too bad. Now we're going to look at this one. We're just doing steps. We're working our way up. Okay? 2 to the n minus 1 equals 128. I have to make them both be base 2 because it's a smaller one, right? Well, we know this is 2 to the n minus 1 equals 2 to the 7. We know that. So if this is true, what can I say for my next step? N minus 1, what? Equals 7. The catch is I want to know what n equals, not n minus 1 equals. So I have to do one more step. I have to add that one over. So n actually equals 8. Follow me? C is actually the same as this one. You just don't see it yet. Because I have this 5 sitting out front. What do I have to do when I have that 5 sitting out front? Divide it. So we're going to divide the 5 over. And we're going to get 2 to the x equals 128. Right? So we have to spot that first step to divide it over every single time. And we're going to do that with the formula later. So 2 to the x equals 2 to the 7. So x must equal 7. Okay? We're going to do B together. B. And by B, I mean middle column. I don't know why I said B. Middle column. So we have 3 to the x equals 6,561. What's my lowest base? 3. So now I'm trying to make 6,561 be 3 to the something. So you give her. 3 to the 4 is 81. 3 to the 5 is not right. I'm thinking 3 to the 6, 3 to the 7. I don't know which one. Maybe it's higher than that. What is it? 3 to the 8. So we get 3 to the x equals 3 to the 8. So what can we say now? X is equal to 8. You try box 2 and 3 in the middle. Did you sign in, Kyle? Yeah. Awesome. So we're going to have 3 to the n minus 1 equals 3 to the 8. So now I can say n minus 1 equals 8. And then I have to add 1. And n equals 9. The third box, what do I have to do first? Put the 4 and 3 together? No, that's illegal. You should get a math ticket. I wish I could hand out math tickets. Like, this is a ticket for a bag of chips or something. If you did 4 times 3. So, we don't want to do that. That's super bad. It's like robbing. It's equally as bad in my head. So, we're not going to put those together. We're going to divide by the 4. And shockingly, surprisingly to you, you're going to realize it equals 6,561, right? Which is the same as 3 to the 8. And then we can say x minus 1 equals 8. Add 1. X equals 9. You try the third column. You don't, but if you make a mistake, you have less part marks and it's written response, right? 125 is 5 to the what? 3. So we have 5 to the 3. So then we can say x equals 3. This one we have 5 to the n minus 1 equals 5 to the 3. So now we can say n minus 1 equals 3. Add 1. 5, please, just so you know, my mic can pick up you better than it can pick up me. Even if you're whispering, it will pick up your conversation. It's like crazy. It can pick up, because it's a conference mic, so it picks you up better than it picks me up. Okay. Divide by 3. 5 to the x minus 1 equals 125. And I know when I taught from home, I could still hear everyone asking questions. 125 is 5 cubed. And then we get x minus 1 equals 3. Add 1. X equals 1. Then we're going to flip over. So that's nothing directly related to geometric, but we need to know how to solve for x like this in the geometric sequences equation. So a geometric sequence is a sequence in which the ratio, not common difference this time, this one, the ratio of consecutive terms is constant. So for example, we have 3, 6, 12, 24, 48, 96. It's kind of a little more noticeable because it goes up faster, right? The other one would just go up by 3s. It's going to take a long time to get to the big number faster. Not this one. This one needs to go away. So in order to get R instead of D, if it's common difference, for a common difference you did term 2 minus term 1, or term 3 minus term 2, or term 4 minus term 3. The latter minus the former, right? Instead of subtracting, for geometric, we divide. So we're going to do term 2 divided by term 1. So in this case, it's going to be 6 divided by 3, which is 2. Now in the last one with common difference, we added that common difference each time, correct? With common ratio, you're going to multiply by it each time. So let's check it out. So I have 2. 3 times 2, 6. 6 times 2, 12. 12 times 2, 24. 24 times 2, 48. 48 times 2, 96. It's geometric. So arithmetic, you add that amount. Geometric, you multiply by that amount. Okay? And just like with common difference, we could add a negative, which is kind of like subtracting, right? Here we could multiply by a fraction, which is actually very similar to division. So, how do we do these ones? We start with term 1. We figure out what it's going up by, and then we raise it to that power. So we get this lovely formula here. So for geometric, you get Tn equals T1 times r to the n minus 1. So for arithmetic sequences, it was Tn equals T1 plus n minus 1d. That was arithmetic, right? Geometric's just this. Tn's the same, T1's the same, n's the same. The only difference is there's an r. So Tn is still last term or general term. T1 is still first term. N is still number of terms. R is just the common ratio. And an example of how to find it is you could do term 2 divided by term 1, or I could do term 4 divided by term 3, or I could do term 100 divided by term 99. I just have to take the former term, or the latter term minus the former term. So the term after minus the term before, right? And by minus, I mean divide. Yeah. Yeah. Still stuck on arithmetic. I'm trying to subtract. All right. So here it says it gives you the common ratio can be found by taking any term except the first and dividing that term by the preceding term. Now you can use the first term, but you have to use it with the second. It's just saying you can't do like the first term divided by no term. Like there's no term to divide it by, right? So you have to start with term 2 at the very least and do the preceding one. So this is term n minus the preceding one. This is the way they can show the formula. So this one, r could equal 15 divided by 5. Or it could equal 45 divided by 15. Or I could do 135 divided by 45. All three of these divided gets me 3. So does it actually matter which one I choose to do? No. I just have to take the one term after minus the one term. Divided by, oh my gosh, I'm going to say minus a whole bunch of times. My head is stuck. Arithmetic. Need to move to geometric. Okay, that's literally the only difference. And a different formula, obviously. So it's not crazy. So let's try these. Determine if the sequence is geometric. Now, in order for it to be geometric, every single one has to go up by that value, right? So if the second, third, fourth, and fifth all go up by that value, but first to second it doesn't, it's not geometric. Every single one has to go up by that value. Okay? So we'll do the first one together. If so, if it is geometric, state the common ratio, so R, and the general term. What's great about the general term in arithmetic, I have to distribute that dn, right? And then collect like terms. We agree? Arithmetic, or geometric, well, this is going to be hard for my brain. Geometric general term, you just fill in n and you just leave out n and leave out tn. So you're going to fill in t1 and r and you're done. You don't have to expand, you don't have to distribute, you don't have to collect like terms. That's it. So we'll go through this first one and see if it's geometric. So to see if it's geometric, it has to have an r, right? The whole way through. So I'm going to do 2 divided by 1 equals 4 divided by 2 equals 8 divided by 4. They all have to equal the same thing if I divide them, correct? So 2 divided by 1 is 2. 4 divided by 2 is 2. 8 divided by 4 is 2. So then I can say this equals 2. If I can say these all equal 2, it's geometric. Right? So it's geometric, and that's my common ratio. And once I do that, I can get the general term. Just like the general term of arithmetic, we leave out the Tn, we leave out the n. Right? We fill in T1, and in this case, we fill in R. So the formula is Tn equals T1 times R to the n minus 1, like that. I put a dot. I never use multiplication symbols anymore because they look like X's. We just fill in T1 and R. So Tn stays Tn in the general, just like it did in arithmetic. T1 is what? 1 times R, which is 2 to the n minus 1. Now, only if T1 is 1 do I not need to write it. Correct? Because 1 times anything is just itself. Correct? I'm not actually putting these two together. It's just because it's a 1, they could give me this. And I just want you to see that because you guys won't know to pick it. I could just give you this as an answer. Both of these are correct. Just note to self, if your T1 is a 1, this could be the answer in the multiple choice, right? Because 1 times anything is itself. Only if T1's a 1. If it's anything else, you have to show it. It can't go away. Okay, you guys are going to try 2 and 3, the second and the third. Keep in mind, if it's not geometric, you can't give me an R, which means you can't give me a general term. Okay, so you're checking for geometric first. If it is, then you can give me the general term. So try that out. So for this one, R should equal 1 divided by 1 should equal 2 divided by 1 should equal 4 divided by 2 should equal 8 divided by 4. See if there's a problem. 1 divided by 1 is 1. 2 divided by 1 is? People are like, it's 2, 2, 2. We'll just ignore that one. You can't. So this would be neither arithmetic nor geometric. It can't be arithmetic because 1 minus 1 is 0, 2 minus 1 is 1. So it's neither. Could I ask a test question that asks if it's geometric, arithmetic, or neither? Totally I can. You do term 2 minus term 1, term 3 minus term 2. Those should all equal if it's arithmetic. Term 2 divided by term 1, term 3 divided by term 2 should all equal if it's geometric. And if neither of those works, it's neither. Okay? Totally a good question to ask at a test. So those don't equal, so it's not geometric. Now this one, I should get 5 divided by negative 1 should equal negative 25 divided by 5 should equal 125 divided by negative 25. Negative 5 divided by 1 is negative 5. Negative 25 divided by 5 is negative 5. 125 divided by negative 25, negative 5. So that's good, right? Then to do our general, we do Tn equals T1, which is negative 1, times R, which is negative 5, to the n minus 1. And you're done. No expansion. You know what's the saddest thing? Everyone does this, and then they go 5 to the n minus 1. And I'm just like, no, it was right. And then you ruined it. Because you'll put these two together. You're like, I can make it better. Do not make it better. Don't fall for that error in the multiple choice. I will have that error in the multiple choice. For a general term, geometric, I'll give a multiple choice answer as 5 to the n minus 1. It's totally wrong. Do not pick it. I'm telling you right now. Informing you of an error that will be on there. Don't pick it. Okay? Yeah? Don't put these two together. It's bad. Illegal. Stuff. Okay. This one, I want you to write the first 4 terms of the geometric. So term 1 is 7. How the heck do I get to term 2? It says geometric, and this is what we're going to have to look for now. We have to watch, because now they could be geometric or arithmetic. Geometric, I multiply by r to get to the next one, right? Arithmetic, I add d to get to the next one. Very different. So we should really read. So, how am I going to get to the next term? I'm going to do what? Multiply by -3. R 7 times -3 is -21. -21 times -3 is positive 63. 63 times -3 is what? -189? True? Did you try it? Yes, good. Okay, you're doing B and C. Giver. C gives you the formula. You're going to have to plug in 1 to get term 1, 2 to get term 2, 3 to get term 3, 4 to get term 4, right? And this one you do what I did. Except you're going to multiply by 1/2. So try them out. All right. So this one, we start at -8. We multiply by 1/2. Multiplying by 1/2 is like dividing by 2. So we're going to get -4. Multiplied by 1/2, -2. Multiplied by 1/2, -1. Did you do that? Now if you're using 1/2 in your calculator, remember you can either use the alpha y equals enter button and it pops up a fraction if you don't have the TI-83s, or you need to put it in a bracket because your calculator only knows a fraction if you use the alpha y equals enter button, or if you put it in brackets, then it knows it's a fraction, right? So you have to do that. This one, term 1 is 3 times 0.6 to the 1 minus 1, which is actually 3, 0.6 to the 0, which is 3. Did you get 3? Because anything to the power of 0 is what? 1. Anything to the power of 0 is 1. So your first term is always going to be just what this front number is, right? This is term 1, formula. Term 2 is 3, 0.6 to the 2 minus 1. 3 times 0.6 is what? What do you get? Pardon? 1.8? Yeah. And then term 3 is 3 times 0.6 to the 3 minus 1. So 3 times 0.6 to the 2, which is 1.08. Is that true?
Yeah, it's 1.08.
Yeah. And then term 4 is 3 and 0.6 to the 4 minus 1, which is 3 times 0.6 to the 3, which is 0.648. Do you agree? So you can represent term 1, 2, 3, 4 as in commas like this, or you could go T1 equals 3, T2, and that still represents the 4 terms. You don't have to put them in spaces with commas, right? It means the same thing. So term 1 to 4 can be represented that way or that way. Your homework is page 39, 1 to 3. Remember at the beginning of class we're going to go through the quiz that I gave today, so make sure you've attempted it, finished it. And then we're finishing up geometric sequences tomorrow. And then we move on to geometric series on Wednesday, and then infinite series. Something is hilarious out there. It's not me, because none of you laugh. But out there, totally hilarious.